This is a reminder that you should feel free to take as much time as you need to write all of the notes down and think about them. Pause the video at your own pace.
Welcome everybody to section 4.4 Polynomial and Rational Inequalities. Check it out. Let's say you wanted to solve this inequality here, x squared minus 4x minus 5. Turns out the absolute dead easiest way to do this is to turn it into a function. This started out as x squared minus 4x minus 5 is greater than 0. I'm just going to take this whole polynomial part and put it right here and call it a function. And then graph it. When you graph it, this is what it looks like. And so if your goal is to figure out when is this function going to be greater than 0, or when is this polynomial going to be greater than 0, then graph it and figure out where the graph is greater than 0. And the graph happens to be greater than 0 in these two regions. So the answer is going to be wherever you see the graph greater than 0. I see the graph greater than 0 when x is less than 1 over here, and when x is greater than 5. And this is the these are the x values for which the function is greater than 0. It's above the x-axis, from negative infinity up to negative 1, not including negative 1, and then also from 5 up to infinity. That's how you write it. Now, the tricky thing comes when you don't have Desmos. You have to kind of predict things without using a graph. So, what you could do is you could, say, factor it. You take that related polynomial, and you have x squared minus 4x minus 5. You factor it, you solve it, you get where the function is going to equal 0. It's going to equal 0 at x equals 5 or x equals negative 1. Basically, what you're doing is you're finding the x-intercepts. You're establishing that the graph is going to cross the x-axis here and here without actually having a graph. Then what you're going to do is you're going to say, well, if it crosses the x-axis at these 2 points, 5 and negative 1, then there's basically 3 options. Everything to the left of to the left of negative 1, in between negative 1 and 5, and after 5. It breaks up the intercepts break up the graph into 3 distinct regions. 1, 2, 3. However, we don't have the graph. Then we're going to take a test point, and we're going to see whether or not that test point is going to produce a positive or a negative value. Because remember, what we're really trying to do is we're really trying to figure out when is this going to be greater than 0. So we'll take some test points and see which test points produce numbers that are greater than 0. So in this interval, we've got a number. I'm just going to pick negative 2. You could have also chosen negative 3, negative 4, negative 6 million. Any of those numbers are in this interval. You take that test value, plug it into the function. You say, what is f of negative 2? Turns out f of negative 2 is positive 7. And because it's positive, then we know that, yes, it's going to be greater than 0. The one test value works, so therefore they all work. Negative 3 would also be a positive number. Negative 6 million will also work as a test value. If one works, they all work, so therefore, yes, we're going to include that interval in our answer. However, you see that this middle interval, you can take a test value of 0. You could have also chosen 1, 2, 3, 4, 4.5, 4.9, 4.99999, any number between negative 1 and 5, not including negative 1 and 5. Take 0, mostly because it's easy to calculate. You say f of 0, what is that? It's negative 5. And therefore, because this is negative, all of those test points are going to be negative, and we don't want to include this interval in the answer. Here we take a test value of 6. Because it's on this interval, we find out that f of 6 is 7. That means and because it's positive, all of the other test values will also be positive. So yes, we include that in our answer. That's how you do it when you don't have Desmos, when you don't have a graphing calculator. Let's do the same thing again here. Well, it's pretty easy to do with a graphing calculator. You graph it. You graph the related function. I mean, the x cubed minus x. You have to turn it into a function. Then you graph it, and you figure out, oh, look, I see it's greater than 0 here. It's greater than 0 here. Not a big deal. So therefore the answer is all the numbers in between -1 and 0 and all the numbers greater than 1, like we see here. That's the answer. Now, if we don't have a graphing calculator, not a big deal. Just make sure you factor this, find the zeros of the function. Find those x-intercepts. There's going to be 3 of them. How do we know? Well, because if you factor, you take the greatest common factor out of here, it's x. What's left is x squared minus 1. If you can factor that here, and you see that the x-intercepts are going to be at 0 and plus or minus 1. So when you don't have Desmos, you got to set up a table, and you can see here the 3 intercepts break it up into 4 intervals. Everything less than -1, everything in between -1 and 0, everything in between 0 and 1, and everything greater than 1. You've got test values for all of these. -2 is in here, -0.5 is here, positive 0.5 is in the interval, and 2 is on this interval. And then you're going to find what those values are when you plug them into the function. Personally, I don't mind using Desmos a little bit to simplify the calculations. Like if you can just ignore the whole graphing part, I still really enjoy having Desmos to run through the calculations very quickly. Mostly because I know that I feel confident in my ability to plug numbers into a function and get out of value. So I don't feel like I need to practice that again. Although if you want to practice that, you should. This just makes plugging numbers into a function and getting numbers out very easy, because you just type in the function here, and then you add a table, and then you say, I want these x1 values. I'm going to tell you what they are, and these are going to be the f of x1 values. It's -6, 0.375, -0.375, and 6. Now, remember, the original asked us, when is this all going to be greater than 0? Well, we can see these test points here, only these 2 are greater than 0. They're positive, so therefore we're going to include them in our answer, and we're not going to include the others. This interval and this interval produce positive numbers greater than 0. Here's something a little bit more complicated, but the process is still the same. Here you can see what we want to do is we've got terms on both sides, and we want to know when these 2 terms are less than or equal to these 2 terms. The related function, if you're going to graph something, you have to bring everything over to one side. So I subtract 11x cubed and 4 to the other side, and so then therefore the function is 3x to the 4th minus 11x cubed plus 10x minus 4, and you have to figure out when that is less than or equal to 0. It's less than or equal to 0 here in these lower regions. And if you just want to zoom in a little bit, because it's incredibly, these are actually 2 different zeros. Here's a zoom in of that region. So you can see there's a little bit in between these 2 zeros that actually goes up just above the x-axis for just a tiny moment and then back down again. And there they are. There's 2 negative regions, therefore you go from this one and is right here, and then this one is right here. Now might be as good a time as any to talk to you about Franklin Delano Roosevelt. He was an incredible president, guided us through World War II, and he's your audio check president for the day. So, rational inequalities. Let's start off with this right here. If we want to solve this, we have to figure out when this is less than 0. Here's the related function. You can graph the related function. Check it out. Here's what it is when it's graphed. And you can see, when is it less than 0? It's only less than 0 for just a tiny part of it. It's positive here, it's negative here, and it's positive here. Turns out that on a graph like this, there are 2, on the previous graphs, it was only ever going to change signs whenever it would cross the x-axis. You could solve the related polynomial function for 0, figure out the zeros of the function turn out to be the x-intercepts, and those x-intercepts are going to break up the intervals. And that's still true here. We need to figure out when f of x is equal to 0, and it does equal 0 right here. But there are more places where it could possibly change signs. It could possibly change signs where the denominator is also equal to 0. So here you can see that it changes from positive to negative where the denominator equals 0, where you have this break in the graph. Collectively, we're going to talk about these two kinds of parts of the graph as critical values. The critical values are the x values where f of x equals 0 or the denominator will equal 0. So here we can see that f of x is going to equal 0 when 3x is equal to 0 and x is equal to 0. So f of x is equal to 0 when x is equal to 0. So that's the x-intercept. That's what we did with the last several examples. But then we also need to worry about when the denominator could equal 0. That's at -6. So the graph could change from positive to negative or negative to positive. The graph could change signs at the where the denominator is equal to 0 or where the function is equal to 0 at these two places. And in fact, it does. It goes from positive to negative to positive. So if you're doing this, so of course the answer is going to be all the numbers in between -6 and 0. That's where the overall rational expression is less than 0, right here. Now, if you don't have Desmos, you've got to identify -6 and 0 as the critical values, and then you've got to take test points, just like we did before. If you don't have Desmos, then you say, well, f of -8, for example, you could have chosen -7 or -10, but I just chose -8. F of -8 equals 12, and that's positive, so it's not a part of the answer. F of -3 is -3, and we're looking for negative numbers, so that is part of the answer. And then f of 3, another test point, f of 3 equals 1, that's positive, so it is not. I just chose those as easy to calculate numbers here. They don't come out to be any decimals. So I want you to figure out how to express that answer, how to express the idea that none of the numbers on this interval less than -6, none of the numbers on this interval anything greater than 0, but only the numbers in between -6 and 0 are part of the answer. How do you express that? I want you to write that down, and then we'll continue with the video. Critical values. Values where the function is equal to 0 or where the denominator is equal to 0. Look at this hairy beast. We've got two rational expressions on either side of an inequality. What are we going to do? Well, what we're going to do, I'll tell you what we're going to do. We're going to create a related function. We're going to bring this entire thing over to the other side here. So it's the left-hand side minus the right-hand side. That's going to be the function. And you can graph it. Here it is. And when is this going to be greater than or equal to 0? It'll be greater than or equal to 0 during this entire interval, during this interval, and that's it. When is it greater than or equal to 0? You can find it right there. And that would be the answer. If you don't have a graphing calculator, then you have to figure out two different things. When is the entire related function equal to 0, and when is the denominator equal to 0? When are we going to have breaks in the graph? So here it is. What I actually did was I moved it back over so that we have both rational expressions equal to each other. Then I cross-multiplied. X minus 3 times x minus 5 is over here, and x plus 4 times x plus 2 is over here. Cross-multiply, FOIL the whole thing, subtract out the like terms, and actually what you get is x is equal to 0.5. That's where the function is going to equal 0. It only equals 0. There's only one 0 of the function. There's only one x-intercept. There's only one solution to this equation right here, and that's x equals 0.5. That's the first critical value. Then the other critical values are where the fractions the denominators are going to equal 0. Of course, right here, you see these two fractions. The denominators are going to equal 0 when x is equal to -4 and where x is equal to +5. So we've got three critical values: -4, +5, and 0.5. So you can set that up like this. Sometimes it's easy to organize yourself in a number line, just because they can have so many critical values. It's easy enough to just draw a line and then -4, 0.5, 5, so you keep yourself straight. That means if you have 3 critical values, then that means you have to test 4 regions. F of 5, sorry, this should be a -5 right here. F of -5 is 7.7. That's good. We're looking for positive numbers. F of 0 is -3.5. We don't want that to be part of the answer. F of 1 is 3.5. That's positive. F of 6 is -7.7. We don't want to include that. So we're going to include all the numbers that are less than -4, all the numbers that are in between 0.5 and 5. Not including. Yes, including. So here are the 2 intervals, and it's worth noting, why is there a bracket right here? Well, it's because we're actually allowed to include 0. Here in the original, it's greater than or equal to. So therefore, even when we solved it, this was greater than or equal to. So these functions are allowed to be exactly equal to 0. So therefore, we can include these any blue points that we found where the function is equal to 0, the x-intercepts. We can include the x-intercepts in our answer. We cannot include where the denominator was equal to 0. So I know we have 3 critical points, but the one critical point that we can include is where the function is equal to 0. It was an x-intercept. The other parts, -4 and 5, we cannot, because -4 and +5 are not values that we can have in the function. Right. So, and you can see even here, it's fun to use Desmos, just to automate the things that we're really good at. I feel like I'm really good at plugging numbers into functions, and I don't really want practice with that, so I can automate this if I want to. You can be the judge of yourself if you want. All right, so I'd like you to start assignment 4D, copy the problem list, and do the first problem, and I'll see you in class.